Hi all, welcome back to the series of UDS sessions. Today we are going to discuss about next service, that is Write Data by Identifier, service 2E. So empowering precise vehicle calibration configuration through advanced diagnostics. This presentation explores the vital role of WDBI in modern automotive systems. So what is Write Data by Identifier? Write Data by Identifier, usually we used to call WDBI, that is Service ID 0x2E, is a fundamental unified diagnostic service defined by ISO 14229. So last time we saw in 14229 UDS diagnostic session, many services are there, more than 20-25 services it supports by 14229. In that services, the WDBI is one of them. It enables external diagnostic tools to precisely write specific data elements directly into an electronic control ECU. So direct data modification allows a targeted parameter. It changes in ECU, particular section of ECU. In particular memory, it will some parameters or values can be updated. It's identifier based, like uses unique data identifiers. Usually we used to call as DIDs for precision. It's very crucial for ECUs, like essential for calibration, configuration, and flashing. A number of functionalities are there. It will be supported by Service 2E. So this is the WDS foundation. It's come from ISO 14229 Unified Diagnostic Services. We already saw. So Unified Diagnostic Services, it's a common language to communicate to the vehicle. It's a standardizer. So that's what we are given. Standardized diagnostics provides a universal language for vehicle communication, streamlining diagnostic process. So it's not any specific to OEMs or manufacturers or suppliers. It's a whatever car or passenger car OEM you take, it's a common across. The way of implementing the UDS services comes to the common. So that's what it has a more weightage. So next two is a service oriented. Defines various diagnostic services including WDBI for specific tasks. So last time what we saw, many services are there. 20 for reading also one services is there. To change the states also one services is there. For security access one service is there. Like that only. For writing also one services is there. That is what WDBI, service 2E, Write Data by Identifier. So that's what it's telling. It's service oriented. And we have next global adaptation, adopted worldwide for vehicle fault diagnosis. That's what it's. If it is common and very beautiful language to communicate to a vehicle, that's what it's global adaptation, adopted worldwide for vehicle fault diagnosis, flashing, and configuration, ensuring broad compatibility. How WDBI works? It's same way how it worked in service 22, like client will be there, server will be there, like client will be our tester and server will be our ECU. It will send a request to the service, a request to the server, and server's process and send back request to the client. In the same way here also it will work. Here only thing is we are sending the request to write the data. Okay. So if you see, WDBI process involves a client sending a request to an ECU specifying the data identifier and the new data. The ECU then processes this request and sends a positive or negative response. First, what we'll send? We'll send a client request using service 2E, service ID we used to call, followed by data identifier. The data identifier has a 2-byte standard. Okay? And data record. What data you want to write? That record we are sending in the request. Then ECU process. It validates the request, whether it is correct request or not, performs security checks, and writes the data to its designated memory location. Each DIDs comes with a unique memory locations. So if you want to write data, if you use that DID right, it will read the memory location of the particular data. Then it will go into that and update the values whatever you requested. Server responses confirms successful data, writes, reports an error. If it is successful, it will be a positive response. If it is error, it will be definitely negative response. So anything we want, positive or negative, you should send. Okay. And here precision via data identifiers. Data identifiers are 2-bit values we already discussed, and it uniquely identifies specific data elements within the ECU. They act as precise addresses, ensuring that write data by identifier service targets exactly the extended parameter. If you see, they have all unique address. Each identifier comes with a unique address in the memory location, and predefined values also will come. So some DIDs we have DIDs comes with a predefined manufacturers, ensuring the standardized access. For example, it may be some calibration, engine calibration values, vehicle identification number, VIN numbers, or mileage, or configuration settings. All these comes, for example, predefined values. And access control. Many critical dates require robust security access before modification, because unauthorized person should not come and write anything they want. There should be restriction. Only authorized person come and they can flash some memory or write some data into the ECU, because anything happen, no, there may be chances of ECU malfunctions, or ECU can get corrupted. So to prevent all these things, security access control will be implemented in this before writing the data. Safeguarding the ECU. The role of security access. Modifying the ECU data is sensitive and requires robust protection, as already know. The security access service 27 service. This is the main service. Here we used to, by this service we are implementing the security access. So this service we will be discussing in the next sessions. Before that, how write it's using security access. Before writing, security should be required. And it precedes WDBI for critical operations, ensuring only authorized persons or tools can make changes. So authentication first. So client must prove authorization before writing, preventing unauthorized access. Failing this, server or our ECU won't allow to write anything into the memory. The seed and key exchange. So security 27 service is come with a seed and key mechanism. So then only security it will send a seed. We request a seed and will manipulate and send the key, and it will some algorithm will be there. Our side key and programmers what algorithm it has, right, in server side there will be one key. It will calculate whatever we have and it has. If it is matches, then it will server unlocks for the writing. So that mechanism will be there. We will be seeing this in security access UDS session. And prevents tampering, protects against malicious attacks, accidental data corruption, and ensures system integrity. So WDBI in action, empowering automotive functions. So already we saw in what and all stages it is useful, right? Maybe it is calibration, configuration, ECU programming. All we use, we are using service 2, and it very plays vital role. Without that, it's very difficult to write particular memory location into a particular data. So suppose if you say calibration only, so we are adjusting engine parameters for optimal performance, fuel efficiency, or emissions compliance. If you see configurations, settings, vehicle options like regional settings, feature activation. So some features based on some regions we used to activate and deactivate features, right? That also we can come with this configuration, that too done by 2E service. And component coding after replacement, and ECU programming. So ECU programming, updating the software for bug fixes, or you want to flash a new software, new feature, or new firmware, and performance enhancements. All that can be done by service 2E. And here mainly the 2E service, write data identifier service, allows the client to write information into the server at an internal location specified by the provided data identifier. So for example, few we'll see. Many more are there. We'll just see a few. For example, ECU coding and configuration. We can update the vehicle or ECU configuration parameters, like enabling, disabling features, or region-specific updates. If you see calibration data update, change calibration values for engine, transmission, or other control systems like fuel maps, sensor thresholds, and all we can change, we can update. Next, VIN programming, write or update the vehicle identification number in the ECU if supports. So if you want to change any VIN number or something, you can do that. If it is supports, you can go for that updation also. And service and maintenance reset, resetting the service indicators, maintenance counters, or adaptation values after repairs. That all we can do from that service 2E. And security key and seed programming. So store new security key or perform the security key access. So new security update happened. No, we need to store in ECU, right? For that, by storing the key in the ECU, we need a service 2E to flash. Okay. And we have some personalization like storing the user preferences such as seat positions, climate settings, and info 10 options. All will be done from 2E service only. And component replacement. Update component specific data after replacing parts. Example, injectors, sensors, batteries. So example, to clearing the non-volatile memory or resetting the learned values. Everything will done here. Okay. Suppose you have one ECU. Okay, that is old ECU. You want to replace that ECU. First you have to take a backup of that whatever it is there. No, we have to data. You have to take backup. For that, what we'll go for? We'll go for read the values. Okay, read it. Then new ECU whatever you have, right, that is new. So here you have to write that data into this ECU using 0x2E service. So here also by ECU replacement, it plays very vital role by copying the data from old ECU to new ECU. We use 2E service. So we'll see one example did 0, 1, 2, 3, 4. Because why I'm taking this did, it's same did I have taken and given example as a read data by identifier session. So it supports both read and write. For example, I have taken same did for understanding purpose. 0x 1, 2, 3, 4. That is 1, 2, 3, 4. Did 1, 2, 3, 4. It supports both read and write operation, and it's related to a temperature value from the sensor. So, for example, you have the 1, 2, 3, 4 did. If you read the did using to service 22, already in that particular location, some values will be there. That value will be reading from service 22. Suppose I have 20. You have value 20. It will be stored in that location. I have a client tester and server ECU. I am requesting the sending the request message to write some data. So here 2E is a SID and 2 bytes of did, and 10 is the value I want to write in that particular location. So once after writing the sending the request, ECU processes and send back the response to the client saying, hey, take the positive response. 6E is nothing but positive response. 2E plus 40 followed by 1, 2, 3, 4 did number. So this means we are sending the positive response. 4 is here PCI length because I am sending the 4 bytes here, and 3 is PCI length. Here I am receiving 3 bytes of information here. So now it is written. Now what I have written? I have written 10. If you read back again, anyway, reading and writing into same memory location. If you read back again, you will see instead of 10, you will see instead of 20, you will see 10, because now new values will be there. This one 10 I have written in this memory location. When you read back, 10 only will read. 20 is got replaced. Like this, we can write into the particular memory. This is write data by identifier. And it supports some NRC also, how post response. So I am sending the 042E 1, 2, 3, 4, 3, 4, 10. This is the correct format. If I sending only this much, I am not sending any record data. Record data is compulsory. Okay, record data, what data you want to write, that you should mention in the request message. If I am not sending, it will send a negative response. Negative response, what will be there? 7F followed by service SID, that is 2E, and it will tell a message it's incomplete. This length is not correct, so it's incorrect message length. That is incorrect message length. It has a service 13. Suppose some service conditions are there. We did not met. Instead of that, we are trying to write some data without meeting the precondition. Then also we will receive some negative response like 7F followed by SID 2E 22. 22 is condition not correct. Suppose 123 I'm requesting, what if did itself is not configured, it's not supported, then that time what will receive? 7f followed by SID 2e 31. 31 is the request out of range. This is what NRC will get. So this analysis is very well explained in a read data by identifier. You can watch by searching read data by identifier by Auto Electro Tech. Then you will get the full information on service NRC supported, how it is, how it looks, what is the supported table. Okay. So next, the power of precision, like WDBI's core advantage. So far we saw what are the benefits, what are the functionalities we can do from service to it. Like that, some advantages like enhanced control, directly manipulate specific data points with the granular control, optimizing vehicle behavior. We already know some particular memory location. We are updating that data into a particular memory location like that. It's very precision. Increased efficiency, streamlined calibration, configuration, and repair process, reducing some service time. Greater flexibility, exactly, it's very gives the great flexibility to work with service to adopt the ECU for different markets or customer requirements easily, supporting diverse applications, exactly. And improved quality also improved, ensures accurate and consistent data across vehicle fleets, minimizing errors and recalls. And we have challenges also, right? Security vulnerabilities if access is not rigorously controlled or leading to a potential misuse, because some unauthorized person will come and write the data. If what if ECU corrupted, then it's very difficult, right? For that, security establishment is very needed, and risk of data corruption with incorrect values or procedures causing malfunctions, a complexity in managing numerous dates and their dependencies across various issues. This and all we need to take care in implementing the security access. But we have other set best practices also. First, we need to implement a robust security access protocol for that particular protocol and encryption. Thoroughly validate data before writing to ECU. You just check what data you are writing, whether it is going to give the meaningful result or not, it is writable or not. Everything you check and calculate before writing the data into the memory. Thorough validate data before writing to the ECUs, including range checks. Maintain comprehensive documentation for all dates and their valid ranges. Utilize version control for calibration data and software updates. Okay, the road ahead. Evolving automotive diagnosis. If you see, as a vehicle becomes more software defined and connected, services like WDBI will continue to evolve. In fact, we'll be seeing much more benefits of service to E in future also, because whatever vehicle it will be a, EV or diesel, petrol or some whatever it may be. So updating the values of firmware or something anywhere with uh, example, for example, calibration or configuration setting, anything is needed. We can't directly write for that. So unified diagnostic services to E is must and required. In each aspect, we'll be using this. So advanced driver assistance systems, ADAS and all, they right, OTA updates, personalization update, or autonomous ADAS also. So in security measures, enhanced security, continuous evaluation of security measures against new cyber threats. So any applications, TUI will be there. It's much evolving. So it will be very beneficial if you learn. Thanks for watching. If you have any comments, please put into a comment section. Thank you.